angle relationships. In this video, we're going to review some angle relationships. You actually learned these last year, but we need to make sure that we remember what they are so that moving forward, we can use them in our two-column proofs. So first of all, take a look at the picture. It says in the picture below, lines X and Y are blank lines. So here's line X, here's line Y, and those are parallel lines. Now line T, he's the guy that kind of goes through them or intersects them, is a transversal. Now when this happens and you have 2 or 3 parallel lines cut by a transversal, we have some special relationships. So first of all, it says label the inside of the parallel lines interior and the outside of the parallel lines exterior. So take a look at your parallel lines and consider them like a road. And if you're driving on the road, you want to drive on the inside of the road. You don't want to drive on the sidewalk. So the inside of the road would be in here. And this, the whole way across, is your interior. Then the sidewalk, where you don't want to drive your car, is your exterior. So out here would be your exterior, and out here would be your exterior. Okay, and it goes the whole way across. So this is also exterior, this is also exterior. Now, second bullet down here, it says use a protractor to measure each of the 8 angles that were formed. Now, I don't have a protractor. If you have one, that would be fantastic. Pause the video, get your protractor, measure your angles. But the key here is it says, well, what do you notice about the angle measures? And it says list which angles have the same measures. So what we should be noticing, and you can kind of notice this without the protractor, what do you notice if I were to ask you to label acute versus obtuse? What do you notice about angle A? And I'm hoping you're noticing that he looks obtuse. He's greater than 90 degrees. Well, if we're looking at this set of 4, which other angles are also obtuse? Well, B's not, D's not, C is. So if you had a protractor, you would actually find that angle A is congruent to angle C. Well, what if we were to jump down here? What are the obtuse angles down here? And the obtuse ones are E and H. So we also know that angle E is congruent to angle H, but more importantly, they're also the same measure as A and C. So we can just say A is congruent to C, which is also congruent to E, which is also congruent to H. All 4 of those angles have the same exact angle measure. Now, if we take a look at our other ones, okay, what about angle B? Angle B is not obtuse. Angle B is acute. He's smaller than 90 degrees. Well, if you look at angle D, so is he. And you also notice if I were to grab this guy and grab this guy, that those are vertical angles. And we already know that vertical angles are congruent. So I know that angle B is congruent to angle D. Then we would come down here, we would measure again, also acute, also vertical. And we should notice that angle B is congruent to angle D, which is also congruent to angle F, which is also congruent to angle G. So that's what we should be noticing there. Moving along. Okay, if we go to the top part, I need to rotate my page. Okay, and these angles that we just pointed out actually have very specific names. So starting out, we're going to start with corresponding angles. If you have colored pencils, that's fantastic. Start with a black one or just your regular pencil right now, and we're going to label our angles as 1, 2, 3, 4, 5, 6, 7, 8. Okay, and in fact, why don't we just go do that for all of these? So 1, 2, 3, 4, 5, 6, 7, 8, and you have to do this 4 times. Okay, and then one more time. Okay, now going back up to corresponding angles. Corresponding angles are angles that are, angles in the same relative position. Angles in, and I know this is redundant, it should really say corresponding positions, but I'm going to put matching positions. Now, what I mean by matching positions, if you have a colored pencil, get a colored pencil. Let's say I circle angle 1. Okay, angle 1, if you look at this parallel line, is on the top or the exterior left. Okay, so, and specifically, I'm just going to go with top of the line on the left. Well, if I go back to this one, top of the line on the left would be number 5. So angle 1 and angle 5 are corresponding. Then, what about number 2? Well, he is on the top, but the right. So down here, top right would be number 6. So 2 and 6 are corresponding. Well, if we go to the bottom, number 3 is on the bottom left. So bottom of this one on the left is number 7. So we have 3 and 7. And then bottom right would be number 4. And bottom right would be number 8. So 4 and 8. So corresponding angles, we've got 1 and 5, 3 and 7, 2 and 6, 4 and 8. Now what we need to know about those is that corresponding angles are congruent, meaning equal. The measure of angle 1 is the same as the measure of angle 5. The measure of angle 2 is the same as the measure of angle 6, etc. Moving on to alternate interior angles. Okay, so angles blank the parallel lines and on blank sides of the blank. Okay, so first of all, alternate interior are angles inside the parallel lines. And on alternate or opposite sides of the transversal. Okay, so get your colored pencil. Let's go find some of these. So here are my parallel lines. If they're interior, they have to be on the inside. So inside, we're talking about 3, 4, 5, and 6. So let's say I pick number 3. He's on the inside. But then they have to be on opposite sides of the transversal. Well, this is the transversal. 5 is on the same side, so 6 is on the opposite side. And we can't pick 4 because 4 is kind of in the same grouping as 3, and they have to be on different parallel lines. One has to be on the top one, one has to be on the bottom one. So 3 and 6. Okay, what if we were to pick 4? Also on the inside, and then 5 is opposite, so 4 and 5. And then can we pick like 1 or 2? And the answer there is no, because it specifically says interior, and all of these other angles are on the exterior, so they don't count. So we only have 3 and 6 and 4 and 5. Now, alternate interior angles are also congruent. So I know the measure of angle 3 is the same as 6, and I know the measure of angle 5 is the same as 4. Alternate exterior. Okay, so this time we said exterior, so they are angles outside the parallel lines. So now we're looking out here and out here. Also says alternate, so they are on opposite sides of the transversal. So outside, we're looking out here, so number 1. Well, if I jump down to this parallel line, the outside would be down here, but it has to be on the opposite side. So if this guy's kind of on the left, then this guy has to be on the right. So 1 and 8. Then we're going to do number 2. hop down to this guy, opposite. He's on the right, this guy's on the left. So then we have 2 and 7. And then they have to be exterior. Okay, so exterior are on the outside. These are not, so that's all we have. Now, typo here. This should say exterior. And we know that alternate exterior angles are also congruent. Okay, so again, 1 has the same measure as 8, 2 has the same measure as 7. And then last, we have our same side interior. Okay, so specifically, notice I said interior again. So angles inside the parallel lines and on the same side of the transversal. So if I go to the inside of the parallel lines, we're in here. Okay, this is inside, and they have to be on the same side. So notice 3 and 5 are on the same side, so they are same side interior. If we go to the other side, we have 4 and 6. They're inside on the same side. They're both on the right. So 4 and 6. And we know that same side interior angles are not congruent. They are supplementary, which means they add to 180 degrees. Do you notice that 4 is the obtuse angle, 6 is the acute angle? So they're not going to have the same measure. Okay, 3 is acute, 5 is obtuse. They're not going to have the same measure.